Okay, let's unpack this. For today's deep dive, we're looking at uh, a very specific scientific reasoning test.
Right, and this wasn't just any test. It was administered to GPT-5.
And the subject matter is, well, it's one of biology's biggest concepts, the randomness of evolutionary mutation.
Exactly. And our mission today is to really frame the conflict here. It's this fundamental disagreement between the modern biological consensus and a challenge rooted in pure logic and probability.
And we're using the AI's response as a kind of lens to look through.
Yeah, to see where deep science and that kind of pure reasoning can sometimes diverge.
So the consensus view is, I mean, it seems straightforward. Modern biologists say mutations are random.
Meaning they aren't guided. There's no internal or external goal directing them.
And then natural selection or, genetic drift decides if they stick around.
And here's a fascinating detail from the source material, Darwin himself. He never actually used the phrase random mutation.
Wow. Okay. So the challenge to that consensus comes from a philosophical place.
A very logical one. It's what's known as the teleological argument.
Hang on, let's define that for everyone. Teleological means.
Simply put, it means goal-directed. The challenge suggests that mutations aren't random in the way we think.
That they might be driven by some kind of directive.
Perhaps, yeah.
Yeah.
Something may be encoded in the genes themselves. The argument is that for something really complex to evolve, you need too many specific mutations to happen in a row.
Before natural selection could even have a chance to work on it.
Exactly.
And the test that GPT-5 took, it used a fantastic example to illustrate this whole problem.
The evolution of invertebrate wings.
A process that, as you said, took millions and millions of years to complete.
Right, but the test, and this is the crucial part, it zooms in on just the first 100 years of that evolution.
The very, very beginning.
The absolute beginning. The anatomical changes back then would have been, well, our source material calls it a small nib, just a tiny bump.
So the question becomes, what good is that? What functional advantage could a minuscule proto-wing possibly offer?
If a wing is only, say, 0.1% of the way to being a wing, can it actually do anything useful?
Right. If it has no immediate function, it's just statistical noise.
Yeah.
So how does the critique frame that improbability?
It's stark. The critique basically says that relying on all these tiny random events, what biologists call genetic drift to line up perfectly,
Is like a magic trick.
I mean, the analogy they used was throwing a lot of construction materials up in the air and they're randomly falling back to Earth in the form of an ocean liner.
Okay, that paints a picture. The mathematical improbability is the entire point of attack.
It is.
So how did GPT-5 handle this? How did it defend the biological consensus against this, logical onslaught?
Well, the model's defense was to clarify the definition. It argued that random mutation means random with respect to fitness.
Okay, that distinction, random with respect to fitness, is key, but it feels a little abstract. What does that actually mean for the organism?
It means the organism doesn't mutate because it needs to survive. The mutation just happens. Then, and only then, does selection determine if it's helpful.
I see. So the need doesn't cause the change.
Correct. And GPT-5 argued that these small nubs could confer other advantages.
Not flight.
Not flight, not yet, but maybe thermoregulation or display, or even just persisting neutrally through genetic drift until it becomes useful later.
And for you, the listener, that idea of a feature evolving for one thing and then being used for another, that's exaptation.
Precisely. Like that small nub for keeping warm is later co-opted for flight.
But the tester concluded GPT-5's defense failed. Why?
This is the core of it. The AI didn't seem to grasp the extreme triviality of the changes in those first 100 years.
It was thinking too far ahead.
In a sense, yes. Those initial tiny alterations couldn't have offered any real advantage for gliding or thermoregulation yet. They were just too small. The AI's defense relied on these functional advantages appearing too quickly.
So it struggled with the sheer improbability of all those tiny, sequential, random steps actually leading somewhere complex.
Exactly. It shows how difficult it is to apply pure, cold logic to these deep scientific paradoxes where, empirical observation has built the consensus.
It's hard to logically overturn established biology without just making different assumptions.
And what's interesting is the tester estimated this model had an IQ of about 130.
And they're going to do it again.
They plan to repeat the test when the model reaches an estimated IQ of 165.
So what does all this mean for you? Well, it means superior reasoning is on the horizon. Which brings us to our final provocative thought for you to chew on.
If an AI with genuinely superior reasoning challenges this core idea of evolution and, for now, fails.
What other foundational scientific misconception might it succeed in challenging next? What deep paradox is just sitting there ripe for a logical dismantling?